What's up, coders? Welcome back to ProgrammingLearn. Today, we're building something really cool, a system resource monitor with Python. Look at this real-time CPU usage, RAM usage, disk space, and live network speed, all in a beautiful dark-theme desktop application. We're using two main libraries. First is Tkinter. It comes built-in into Python and handles everything visual. All window, labels, progress bars, colors, fonts, all of it. I'm importing it as TK and also importing TTK for temp widget that look more modern. Second is Psutil, short for proxies and system utilities. This is the library that actually talks to your operating system and reads your hardware data. CPU usage, RAM, disk space, network traffic, Psutil handles all of it. Psutil isn't built into Python, so you'll need to install it. Open your terminal and type pip install Psutil. Hit enter, and you're good to go. We create a class called SystemMonitor. That is our main application container. Inside init, we store the root window, set the title to ProgrammingLearn SystemMonitor, set the window size to 400 by 500 pixels, and configure a dark background color. Now we style our progress bars. By default, Tkinter's progress bars looked outdated. We switch to the clam theme, which is more modern. Set the thickness to 20 pixels for better visibility, and use a nice blue color that matches our dark theme perfectly. We add a header label at the top. System Resource Monitor in Hold Helvetica font. The background matches our dark theme, and the text is a soft white color. The pack method displays it in the window. We store the initial network statistics. Psutil gives us total bytes and speed, but we want speed, kilobyte per second. So we save the current values so we can compare them 1 second later and calculate the difference. This is how we'll get our download and upload speeds. Now, instead of writing the same code 4 times for our 4 sections, CPU, RAM, disk, and network, we're going to create helper methods. This is the dry principle. Don't repeat yourself. It keeps our code cleaner and easier to maintain. The first helper method creates each section. It takes a title and initial value, creates a frame container, and adds 2 labels, the title on the left and the value on the right. Returns the value label so we can update it later. This way, we don't have to write the same label code 4 separate times. This second helper method creates our progress bar. It uses the style we configured earlier, sets a length of 340 pixels, and returns the bar so we can update its value later. Using these helpers, we built all 4 sections in just a few lines. Each section gets a label and a progress bar. We store references to all of them, so we can update the data later. This is much cleaner than writing everything out 4 times. Full source code is available in my Telegram channel, link in the description. Go grab it out and follow along. Now let's build the most important part, the update loop. This is the brain of our application, the update metrics method. This is what runs every second, fetches fresh data, and updates our UI. Without this, our app will be static and useless. We start with CPU. Psutil.cpu% gives us the current CPU loads as a number between 0 and 100. We update the label text and the progress bar value with this number. Both the text and the bar will show the same percentage. Next is RAM. Psutil.virtualMemory returns an object with memory detail. We're specifically using the % attribute, which tells us what percentage of RAM is currently in use. Same pattern. Update the label and the bar. For disk, we use psutil.diskUsage, which gives us disk usage for the root directory. On Windows, you'd use something like this instead. The % attribute tells us how full the disk is. We update both the label and the bar. Network is different. Psutil gives us total bytes sent and received science boot. Cumulative totals that keep growing. To get a speed, we take the current totals, subtract the total from 1 second ago, and divide by 1024 to convert bytes to kilobytes. This gives us download and upload speed in kilobytes per second. Finally, we call this. This is the magic line that makes our app live. It tells Tkinter wait 1000 milliseconds, then run this same function again. This creates a continuous loop that updates every second without freezing the window. This is much better than using a while loop, which would lock up your entire application. At the bottom of our script, we have the started Python guard. We create the Tkinter root window. Initialize our SystemMonitor class and start the main event loop with root.main loop. This keeps the window open and responsive until you close it. Now we run it, Python main.py, and look at that. Everything comes to life. CPU usage, RAM usage, disk space, and network speed, all updating in real time. This is a fully functional SystemMonitor built in under 100 lines of Python. If this code helped you out, smash that like button so I know to make more projects just like it. And comment Python power below if you got this running on your machine. I'd love to know. Subscribe and turn on notifications so you never miss a step-by-step guide like this. We're building a library of Python project here at ProgrammingLearn, and I'd love to have you along for the ride. Happy coding, and I'll see you in the next video.